Good morning. We're just going to take a quick look at some Fusion 360 manufacturing here. We have a German pro user here who has a Hypotherm and is just wondering about some of the ways they can create different tools for different materials in Fusion 360. So let's go through some of that. He said down here in a note that he's looking at materials between 1 and 5 millimeters thickness. We can look over at the metric side of the charts. I might unwittingly be switching back and forth from imperial and metric a little bit, but either way, it's the same workflow, regardless what units you're using. All right, so let's go into Fusion 360 and let's make a few different items of a few different thicknesses that we'll use. Or we can make one item and just apply a few different thicknesses to it. That'd be fine too. Let's do just a really simple sketch. Start in the XY plane. Gonna select the rectangle. I'm gonna use the center point rectangle. I'm just gonna pull out a random size rectangle. I'll use the offset tool. And here I'm just going to make some holes in here just to make it a more realistic item. It's a good way to use the constraints. Let's see what size hole we want to do here. It's not what I want. This one. 0.5. There we go. Let's make it a little bigger. 3/4 of an inch holes. Okay. We have a plate with a few holes in it. Maybe we'll throw another feature in here. Maybe just a letter or something. We'll just put 45 XP, sure. Center that, make it a little bigger. Maybe not that big. Perfect. Do a little bit wider character spacing. Perfect. 45 XP. Let's explode this, which isn't the edit button. Oh, perfect. Oh, this one didn't like it. Anyways, I'll fix that. We're getting a little bit out of where we need to be here. Excuse me. Let's fix this. There's obviously a break in here. There's a little break in there. Sometimes that happens with some weird fonts. It's right there, I bet. Right there, or there. Anyways, we're totally off path right now, but we'll be back on track here in a second. There, that worked. Okay, let's extrude this, and we'll call it 1/4 inch. But really, once we get into the manufacturing part, we can change whatever we want from there. So let's get into manufacturing. And from here, we create a setup, which isn't this button. I'm in the wrong manufacturing space. We're going to get over to fabrication, setup, bottom left. Perfect. Now, we need a cutting tool. So we'll go into 2D profile, we'll select tool, and from here, This is our tool menu to create tools in. So let's create a couple tools in here. We're going to go to our local library. In our library, we're going to add a tool, Plasma, and we'll call this the 45XP. We're going to do 1/4 inch. Let's call it aluminum. Perfect. So under the cutter type, we will now go into the manual and start populating this. So the 45XP manual is, I think Jim linked it here. I have it on my computer somewhere too. Right here. The German version of the manual. Or, oh, it says English. Okay, that's fine. It doesn't matter either way. We're looking at numbers, not letters. So I'm just racing down here. I should have just done it on the index, but just looking for the first page going into, oh, the 45, excuse me. I was looking at the 85XP manual has the kerf widths separate from the cut charts. The 45 has the kerf widths on the cut charts. So that's great. All right, so we're going through the cut charts. We're going to find aluminum, 45 amp. I'll zoom this in a bit. And I went 1/4 inch, which let's say is 4 mil. So I'm going to use a 1/4 inch chart. You can use the 4 mil chart. So we go in here and look, and it wants a torch to work distance of 0.06 inches or 1.5 millimeter. And then it wants a pierce height, which is 250% of the torch to work distance. So in this case, it's 3.8, which makes, is that really 3.8 is 250? Let me just look at a calculator here for a second. That seems weird. $1.5 times 250 equals 375. Oh, they just rounded it up. That's why it's a weird number. Okay. And then our pierce height is here. We want to start piercing at a higher height so we're not spraying a bunch of slag or heat up into our torch. The pierce delay is 0.5 of a second. If we're using a Pro, we're going to add another 0.5 of a second to that for latency. And then we'll look at our best quality settings here. So we have a cut speed of 70 inches per minute, a voltage of 137 volts, and a kerf width of 0.063. So up here it would be a kerf width of 0.15. So we'll go into here, and under both nozzle diameter and kerf width, I'm going to write in the kerf width. 0.018 or 1.5 millimeters. Perfect. We don't care about the holder. We're going to populate this. This is the only part that's going to actually move forward in our calculations. None of this stuff actually works forward, but it might one day, so just fill it out for now. So it said 70 inches per minute. We'll write that in here. Cut height was 0.06. Pierce height was 0.15. I'm doing it all imperial. Cutting power is 45 amps. Piercing power is 45 amps. Pierce time is 0.5. We won't add the latency in here. Air pressure, 85 psi, and it's air. Cutting process, that's fine. It's my 43rd tool in here. Accept. So now we've created this new tool here. And I'm going to create one more tool for, let's say we're cutting the same shape out of 14 gauge steel, which is like 1 mil. We're going to go back to the manual, and I'll create another tool. So let's say we're also going to cut the same exact thing out of 14 gauge. So let's go into 14 gauge mild steel. We're going to find our 14 gauge, or 14 gauges, mild steel, 45 amps. We'll find our 14 gauge here. A lot of the same figures, a little shorter pierce delay, faster cutting speed, smaller kerf width. So we'll go into Fusion 360. We're going to add another tool, plasma cutter. Description of this is going to be 45 XP mild steel 14 gauge. Perfect. So I think it was 0.045 was the kerf width. Let's go back and take a look. Yeah, 0.045, 0.045. And then from here, our cutting speed was quite a bit faster. Let's take a look. They want us to cut at 225 inches per minute. So let's put that in. Put in our pierce, our cut height. We'll put in our pierce height. Our cutting power again. None of these actually go forward in the program. I just like to fill it out honestly. Perfect. And one thing I'm going to do, which I didn't do on the last tool, but I'll update it, is I do also like to put the nominal cutting voltage in this line, because then I can refer to it later without looking back at the manual. So our nominal cutting voltage for that would be 128. So I'm going to just write that in the description line, 128 volts. Accept. I'm going to go back and edit this one. And I'll also put that in there too for its voltage, which was, I don't know, go back and look. It's going to be 100 or something. $137 volts. All right, I'm going to make two different cutting paths now with these two different tools on the same body. So we'll start off using the 1/4 inch. Select. Perfect. Just going to select this whole piece here. Let me zoom in here to this contour menu. So I selected, I'm going to deselect, I just selected this whole body as a face contour, and then I'm going to move over. I like to drop the tolerance a little bit. I find that it limits the G-code, reduces the G-code. I'm going to add smoothing. Myself, I like finishing overlap, especially with aluminum. You probably would add some feed optimization in here. Don't get too hung up on this stuff right now. This is just an example. Yeah. Okay. Now we're going to go into the linking, which is your lead in and lead out. So I'll do a little bit of a lead in radius. A little bit of a lead in, no lead out, no pierce clearance. And let's calculate this toolpath. So it's drawn this toolpath. It seems all right. We could do the holes separately and get a little better geometry going in and out of that, but for simplicity's sake, let's do this. Okay, I'm going to move into simulation. We're going to just take a quick look at how this will simulate. And it does appear like it's going to cut happily. Okay. Exit simulation. Perfect. So there's my one tool path. I could now just select this setup, go into NC program, write in my description of what this cut file is going to be, which is, let's say, 1/4 test, 45 XP. I'm not actually going to load a program. Then make sure you have your cut height in here, your spring back. This is a whole rabbit hole in itself. You're going to want to check your spring back. There's lots of forum posts on that. I'm going to set mine to 0. pierce delay on the 1/4 inch is going to be near a second, so we will put the 1 second in, and the pierce height is good. Perfect. Post. So now we've posted one for 1/4 inch. Now I want to make another one that's going to cut out of 14 gauge. So I'm going to create a new setup, setup 2. I'm going to put the stock box point origin to the bottom left hand corner. Okay. And while I go to generate this one, I'm going to select the other tool we made in the list, which I go into my local library to find. That's where you want to be saving stuff. 14 gauge mild steel. Okay. And we'll go through the same steps for selection. And none of this stuff's really written in stone. Depending on what you're cutting, how you're cutting, it's going to vary. People have their own way of going about it. I like to stick close to the book numbers because I find that they are quite good. All right, now we've developed this new toolpath for cutting it out of 14 gauge. So it's basically the exact same toolpath. It's just running a little bit faster. Yeah, I could have picked a better example where they do have different cut heights, or they do have a different kerf width too, which means that then this line where the cutting happens is going to be put at a different width away from the actual cut line, because this kerf width is a different width in the 14 gauge than it is in the 1/4 inch, which means that this line can be, or should be, closer to the actual cut line. So we'll go in here and just watch this simulation again. It'll be very similar to the other one. It might have loaded slightly different. Nah, it took the exact same path. All right. Now we have this one. I can go up here, click Setup 2, make sure I have Setup 2 selected, move up to the G-code menu, and here I can go 45 XP test 14 gauge, and then fill out all this stuff, which is right now, except I'll go down with the pierce delay and post. Now I'm cutting the same thing out of 2 different gauges with 2 different tool types. That's kind of a quick and dirty way of how some of this tool development works. I hope that helps you along. Take care.